Hello students, Stride here. Today we're going to be starting into Chapter 11, Stoichiometry. Section 1 we will be doing today, defining stoichiometry. Later we'll do Section 11.2, stoichiometric calculations, 11.3, limiting reactions, 11.4% yield. Objectives for Section 11.1. You'll need to be able to describe the types of relationships indicated by a balanced chemical reaction. You'll need to be able to state mole ratios from a balanced chemical equation. We'll review vocab. A reactant is a starting substance in a chemical reaction. New vocab we'll get to as we go through the notes. Stoichiometry and mole ratio. Main idea for this section: the amount of each reactant present at the start of a chemical reaction determines how much product can form. First part we'll look at particle and mole relationships. As chemical reactions, they will stop when one of the reactants is used up. Stoichiometry, defined to be the study of quantitative relationships between the amounts of reactants used and the amounts of products formed by a chemical reaction. Stoichiometry based on the law of conservation of mass. Mass of reactants equals the mass of the products. When we're dealing with chemical reactions, such as this particular reaction, iron plus oxygen yields iron trioxide, we might think of it in terms of atoms and molecules, and formula units are representative particles. More often we'll think of it in terms of moles, but when we measure things out, we'll always have to measure them out in grams. And the law of conservation of mass, whatever we start with in mass, we have to end up with in mass. So a lot of different ways we can think about a chemical reaction. Mole ratio, one of our key terms, some ratio between the numbers of moles of any substances in a balanced chemical equation. The number of mole ratios that can be written for any equation is going to be n times n minus 1, where n is the number of species, the number of substances present in the chemical reaction. Which is following is a correct mole ratio for the chemical reaction. You see it's B. And the reason it is because 3 moles of Br matches to that, relates to 2 moles of Al, matches that. The other ones, on A, we're missing a 2. On B, it should be 3 moles of Br2. On D, should have 3 moles of Br2 for every 2 moles of Al. Here, how many mole ratios can be written for the following chemical reaction? We have 3 species, so we take 3 times 2 gives us 6. We will do some work in class on figuring out how many mole ratios there are, and a few other things relating to this unit. So that's brief introduction into stoichiometry. That's all for now.